by itself. I don't, that's just so stupid. Sorry, it's gonna be cut off today. Okay. So you see my screen now? Yeah?
I mean, are we supposed to be seeing like an equation and like
Yeah.
a chart? Okay,
Yeah.
yeah.
Yeah, I
So,
see it.
right. So this, remember, this is our way of figuring out if our fit is good, right? Or fit. Yeah. If our predictions are good, right? Right. So this is called a performance measure, right? So this is from the section, pick a performance measure, right? So this is the performance measure. It's saying how well are you doing, right? When you're trying to predict. Okay, and we're going to take this apart. Here's our data, just a little snippet so you can see it. And we're going to look at all of what all of this means, okay? Because even though, like I said, you don't need to go the ins and outs of every equation, but something like a performance measure, it is good to understand what it is. Because performance measures, picking a performance measure is something that can really determine how well your prediction algorithm works, okay? You know what I mean? So, all right. So here, let's just look. And this, I wonder if, since you guys have had statistics, I wonder if this maybe looks a little complicated, but I can tell you that it's very similar in idea to the standard deviation, right? So let's just review what the standard deviation is just for fun, because it looks a lot like that. Go away, go away. Zoom thing is in my way. Thank you. Okay, so let's look at the standard deviation. So the standard deviation sigma of, if just of data, that's right, is something like, the hold on. So it looks a lot like this. One of the number of samples, the sum of I equal 1 to the number of samples, and then it would be the number of the sample, right? Each sample minus the mean, right? Minus the mean of the data. I call that X bar, okay? And we square that, and you're summing over them all, right? And then there's a square root. Now, how many of you guys remember something vaguely like that from statistics?
Very vaguely.
Very vaguely. Hannah and Maggie?
Kind of.
Kinda. Well, you remember what the standard deviation is, right?
Yeah.
Right. So like if you have a little, let's say we'll just draw a nice little normal distribution for the heck of it. This is the mean for a normal distribution, and something like this width is sigma, right? So it's how wide is the distribution. But really, let's examine what it is, right? So this xi is just every data set. So let's pretend, just for fun, that this is your data set, median income. Okay, you don't have any other things, just this. And this has a mean of, I don't know, let's call, so let's let xi be median income. I didn't calculate the income. Sorry, give me a second. I'm going to move you guys. You guys are kind of in the way there. All right, there we go. So median income. Okay. And then there's the mean, and let's say, and that's X bar. And I don't know, I could go back to my spreadsheet and calculate it, but it's kind of a pain. I don't want to do that right now. I don't know, I'm going to guess. Let's say 5.0. Maybe, right? So $50,000 is the mean of this column, okay? So this thing up here is saying, hey, take every X, like for instance, 8.3252, subtract off the mean, so 8.3252 minus 5 is 3.3252, right? So the difference from the mean, how far is it from the mean? So that's asking like, maybe that point is like right here, right? And it's saying, how far is it from the mean, right? How far is it? Well, it's 3.3252 away from the mean, right? And then it says, oh, square that, because I don't care if it's over here. Like, in other words, if it's 4.03, it's going to be, the difference is going to be a negative number, but I don't really care about whether it's on one side of the mean or the other side of the mean. I don't really care. I just want to know how far, right? So I square that value because I don't really care that it's negatives and positives, right? And then I take the average. I literally average all of those squared numbers. That's what this does. It adds them all, right? And then it divides by the total number, right? And the total number of this is like, let me go back to my thing real quick. You can't see this, but I always forget what it is. But I'm just going to scroll down to the end of this data set. Come on. Okay, well, I passed it. Excel is annoying, really. It's really annoying. Okay, so M in this case is, I just lost it, 20640. So 20,640 values, right? So you average each one of the differences from the mean, square it because you don't care about it's positive or negative. And so you get the average distance from the mean, which hopefully makes sense that that would be the width of the distribution, right? It's the average distance from the mean of each of your points. Sort of, because you square it, but, right? And then you take the square root, because the square of this, if you square both sides, this would be sigma squared. That's the variance, which you might have also heard from statistics, right? So this is very similar. Look at the form. This is very similar. And this sigma, I'm going to write down here again. I could have written a slightly different way, and for people who've done statistics, it might ring more of a bell. I don't know if it will or not. But we use this notation with the brackets to mean average, and it's the average of xi minus x bar. So this is sigma squared. So that's these guys mean average. I don't know if you've ever seen that. Maybe in statistics they called it expectation value. Everyone heard that before?
Briefly.
Briefly, right. Because mean and expectation value of the same word. Mean, average, and expectation value all mean the same thing in statistics. Okay? So this notation is very often used in sort of formal statistics that you might have seen. With the little brackets, it just means average. So it takes away this sum and 1 over m, but it's the same. You have to do the same thing to get it. It's just a shorthand for saying, hey, just do the average, which of course always means sum up your values and divide by the number of things, right? Sum up whatever you're averaging and divide by the number of things, right? Got me? Okay, let's look over here. This looks very, very similar to this. And in some sense, it's kind of a similar thing, because it's saying, hey, I have my values x. In this case, we have to kind of back up a little, but let's forget about the h for a second, and let's pretend that we just have one feature. So let's let our one feature be medium income. All right, so I'm going to go, let's pretend. So pretend we have one feature, median income, and we want, that should be a period, want to predict, of course, median house value.
And again, this would be example of a univariate regression with the multiple regression.
So if it's only one feature, it's a univariate, like you just said, but it is, right, it is a, one-dimensional or just plain linear regression, right? So instead of multiple, it's, I don't know what people actually have a word for that. It's just regression, right?
Oh, that's right, because multiple regression is where it has more than one feature.
That's right. So that's the real problem we're going to be doing. But right now, we're just going to say, hey, let's just have one feature. Median income. We want to predict median house value. median underscore house value. Right? Okay, so in that case, this performance measure that's going to be testing our algorithm, right, is going to be, so in that case, we have RMSE. This is called the root, right, root mean square, mean square evaluation, right? Okay, or estimator. Evaluation or estimator, right? So root mean square, you can see why it's the root, square root. It's the mean, that's this stuff, right? And it's the square, kind of like this. Okay, and that is going to, I'm just going to leave this off for a second. I'm just going to go here. I'll tell you about that in a minute. In that case, it's going to look like this, right? It's going to be 1 over m, and it's going to be our sum, which is, this is just the average. This machinery you see right here with the 1 over m, the sum is just the average, like we said. It's how you do an average. And what are you averaging? You're having this stuff inside the sum. And we have h still, because h is whatever algorithm you're using, okay? Minus y I, okay? Squared. And I want you to notice something here. Now I can't do it when I'm writing on this board, but here they use a bold, right? See the bold X, and over here it's also bold, right? So bold font. This is meaningful, actually. Okay, this is not bold. This is just regular old font. So the bold means something. It means that this is more than one thing, right? It's not just median income. It's median income and households and population and total bedrooms, and it's all those things. That's what the bold means. It means the same thing here. We'll get to that. But over here, I'm not using bold. I can't really do that, like I said, but I just want to point it out to you. But here, it's not bold. Okay, so what does this mean? So h of x, and let's just say h of x1. Okay, what is it? Well, x1, if I look up here, is 8.3252, right? So x1 is equal to, 8.3252. In other words, $83,252 a year, right? And then my h is something I do to x, right? This is an input, and h is something I do. Now let's say my model, and it's a super terrible model, but let's say my model was that I'm going to multiply the median income by something, right? And say, hey, well, that'll be the median house value. That's my prediction, right? So tell me, just looking at this one piece of data right here, of course, that's not how you'd actually do this, but what could I multiply my median income by to get this value, 452,600? And I'll do the same. You might need to whip out your calculator. What do you think? Keep reaching with the wrong model. And use your median income in terms of thousands instead of 8. You know, like I said, 83,252.
Oh, oops, and I gotta redo it.
Okay, sorry.
No, you're okay. Did anybody else get it while I redo this?
I'm lacking. I'm sorry.
What'd you say?
She was asking if anybody else got it. I said, no, I'm lacking. I'm sorry.
All right. I'll give you a minute.
All right, well, this is definitely not the right answer. Can say that for certain.
Okay, tell me what you got.
I got 0.32651 and then it keeps going. This is not the right answer.
Okay. Well, let me see. Where is my calculator? Oh, yeah. There
I'm doing this on a phone calculator. Is that okay? Or
yeah, did you say 0 what?
0.32651.
Oh, yeah.
Yeah.
Right now. So what do we have to do to figure out the figure out what we need to multiply the median income by to get the median house value for this? What operation do we need to do? Should we write it down as an equation? That might help, right?
Yes.
So I'm gonna so median income times x. Well, actually, let's not use x because that can confuse everybody. Just use another variable like a is equal to median, and I'm just going to write house. So we have 83,252 times a is equal to 452,600. Yeah? Will that help you?
Yes. Give me one moment. I need to move my little squares because you drew on the far right side and the little like images of everyone are blocking it. Okay.
Oh, of course. It's always annoying.
Okay. This time I got 5.436506.
Yeah.
Yay.
Everybody on the same page?
Oh, well, I tried to show it, but yeah, 5.4.
Good.
Yeah, I got it.
Yeah, good. So A is equal to 5.4. I'm going to round up to 4.4. Okay? Okay, so my model says take in the value of median income, X1, and actually it has to multiply by 10 as well because I'm using it in terms of 80,000, right? So multiply by 10,000, sorry, by 10,000. So multiply by 10,000 and also multiply by 544, right? Make sense? Yeah?
Yes.
So in other words, H, so let's go, H of X I, so any X, this is my model, equals the XI, whatever the XI is, so whatever the income is, times 10,000, and then also times 5.44. But of course I can combine these, but whatever. Yeah? So let's say that's my model. That is my model, right? I only have one thing I'm using to predict, and that's the median income. And my prediction is really dumb. It just says, hey, multiply your X, whatever the median income is, by $10,000. I mean, $10,000 and a factor of 5.44. And this is my prediction. And the other thing in the book that they use to note a prediction is Y hat. I. And this means prediction of, whatever you want, right? The label, right? And our label in this case is the median house value, right? So that's what this Y is here. Well, I will explain that in a second. Give me a second. So it's a terrible model, and you can probably see why. Can tell me what happens for your next data point. See if that works. So use this little formula for the next data point, this guy. Let's see. Tell me what your prediction is. What is y hat of 2?
Wait, I'm sorry. Can you like rephrase that?
Yeah.
You cut out for me. I
Oh,
apologize.
I'm sorry. Okay. So here's our model, right? Our crappy model
Mhm.
says take your median income, multiply by 10,000, and then multiply by 5.44, and that should be your prediction for the median house value. I want you to calculate our prediction for the second one here, right? For the second median income value. Let's see what this formula gives us, because we use the same formula now for all of them. Okay,
Yeah.
the same model.
So would XI be would that be the median income that we insert right there to times by 10,000?
Yeah. So in other words, if I were going to write this as a formula, right, I'd put X2, the median income, and then times 10,000 times 5.44. And what do you get?
I got $451,596.16.
Okay, one more time. 400 what?
451, comma 596 decimal 16.
And I'm just going to round that up to 596. Yeah? How well did it do?
It was off a little bit from what it looks like.
Like 100,000, you mean?
Yeah, I guess.
You're like,
you throw it around that much money, it's off a little bit.
He said it did okay, or like it did a little off. I was like, oh, Mitch must be secretly rich.
Yeah,
10,000 like difference of that.
It's the complete opposite. I have no idea how much that money is worth. Right?
Fair,
I think $100 is a lot. So
right.
100. What's 100,000?
What's 100,000? Yeah. Yeah. So it didn't do great because our model sucks, right? It's a terrible model. We only used one data point to even try to do anything with it, right? We just said, hey, let's take the first data point and let's figure out what we have to multiply that median income by to get the house value, and that was our model. Like, it's really terrible. And let's just see, because we can go through this calculation here just for that one point, right? We can actually figure out what is the difference, of course. So inside this, right, we have to average over all of the points, and I'm not going to make you do that, although certainly we can do that on a spreadsheet, no problem, easy, right? Like super easy. And I might make you do that during your asynchronous part. But anyway, so here, let's just calculate this. Okay, so remember we'll do that for that one. So H of X2, we just calculated, right, is 451,596. And Y2, for the actual real value, the label, it's called the label, right? Okay, is 358,500, right? So we have to take the difference between these two here and square it. So let's see. We have H, I'm going to write it again, X2 minus Y2 and squared. And so that's going to be 451,596 minus 358,500. Someone tell me what that is again. What that is, this difference is.
I just had it. It was 98 here. Hold on, and then I accidentally deleted it. But that's what it started with. 98 minus 58,500. Oh, sorry, not 98. Sorry, $93,096.
And then square that for me, would you?
You got it. 1 second. 9396. I don't know if this is right, but I got 305.11.
Not 0.11. Someone square that, or try it again, Hannah. I'll do it as well. Sorry, my calculator not working here. 93096. 93096 squared. Yeah, it's a big number.
I got 8,866,865.
Yeah. So
yes, I was incorrect. I apologize.
Very, very big number. And I'm just going to abbreviate this. So 8.67, and then I've got to count the number to put it in scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9. Yeah, so you get like a billion, basically, right? So I know that seems like a big number, but remember we're squaring this so that we don't have negative numbers anywhere, and they're all going to be squared, right? And we're going to take the square root at the end. Okay, so let's do one more. Oh, we have no time left. Brr. Okay, if we do one more though, we can do real quick. Let's do this. Oh, that should be a 3. I'll write it down. Someone punch it in the calculator for me, okay? So I will do the first thing, the model, right? Because we need to do the model here on X3. So we have 7.2574. That's that next median income. And then I need to multiply it by 10,000 and by 5.44. Okay, so I get 394,803, and then minus the actual value, which is this guy. So we did a little better on that one, 352,100, and then squared. Can someone give me that number after it's squared?
I got 1,823 and 564,209. Does that make sense?
Okay,
Is that what you got, Mitch?
Yeah. So I'm going to do 1.8 times 10 to the 6.
Yeah.
Okay.
Okay, cool.
Okay. So now imagine there was only 2 data points in this set, right? 2 and 3, and we'll ignore 1 for a second because we didn't. Did we do 1? Oh, we didn't figure out for 1. But now you'd add this number to this number, right? Because it's an average, and then you divide by 2.
Would the 1.8 be times 10 to the 9?
Is it 10 to the 9 or 10 to the 6? You said it was 1 million, Hannah. I didn't pay attention to what.
Oh wait, I got if according to my number, it should be 10 to the 9.
Okay, 10 to the 9. All right, fine.
It is 10 to the 9th. I apologize.
There we go. It's a billion, not a million. Okay. Only a factor of 1,000. Okay.
Yeah, that's little money. What are you talking
about?
about?
I know we're basically done. But let me finish this. So you would add this number to this number and then divide by 2 if you only had 2 data points, right? So m would be 2, and then you take the square root.
Oh,
right?
okay, cool.
So I'm going to do that real quick, and then we're going to get off. I'm sorry, we're a little late. 1.889, 8.679 plus 2, and then
Just add it together and then divide by 2.
and then square root. And what we get is, so after that,
whoa, big numbers.
right, big numbers, 72,353. So this is what we get. This is the average distance from the real value of median income. So it's off by like $72,000
That's not
on average of our 2 samples we did already.
That's not a lot.
Ooh.
It's whatever. No, it's not. It's a lot.
So, you'd probably be fired if this was, that wouldn't be good. So, but that's the idea of this measure, right? The measure is like, hey, your model sucks. And you want to minimize this measure. Anyway, we got to get off. And I'm going to meet with Maggie afterwards, and I will be putting a bunch more stuff on like this for you for this coming week. All right. See you guys. Maggie, stay on.
Thank you. Bye.
All right. Bye.
Hello.
Hey, I'm just going to pause the recording or stop